Hello everyone, here's a tricky question based on chemical equilibrium. I say tricky because little bit of math is involved, otherwise it is a straightforward question. The equilibrium constant for decomposition of water is 8 times 10 to the power minus 3 at 2300 Kelvin and total pressure at equilibrium is 1 bar. Under this condition, what is the degree of dissociation alpha of water is? We have to find out the answer in terms of 10 to the power minus 2. We have to find out the nearest integer value. And the condition given here is alpha is negligible with respect to 1. That means alpha is very less than 1. The delta G value is given as positive. Even at this temperature, if the delta G value is highly positive, what it means is that the reaction is highly non-spontaneous. That's what it means. Other than that, we are not going to use the delta G value here. Let us first write the ice table. We have water getting decomposed as H2 gas and O2 gas. The stoichiometric mole ratio here is 1 mole, 1 mole and half a mole. But if we are writing the ice table, then at T equal to 0, we have 1 mole here, but we will not have anything about H2 or O2. When T equal to T, the change happening here is minus alpha. Here it would be plus alpha. Here it would be plus alpha by 2 because of the stoichiometric coefficient. So therefore, at T equal to T equilibrium, it is 1 minus alpha. This will be plus alpha. This will be plus alpha by 2. So therefore, the total number of moles is equal to 1 minus alpha plus alpha by 2. So this means total number of moles is equal to 1 plus alpha by 2. Now we know that Kp is equal to partial pressure of H2 times partial pressure of O2 to the whole power 1 by 2 divided by partial pressure of water. Everything is in the gas phase, that's why I am taking it as Kp. Now we have to find out the partial pressure of everything. Partial pressure of single entity is equal to mole fraction times total pressure. Total pressure is given as 1 bar here. So we are just going to multiply with 1. So therefore, partial pressure of water is equal to 1 minus alpha divided by 1 plus alpha by 2 because mole fraction is equal to the component divided by the total. That's how we came here. And then partial pressure of H2 will be equal to alpha divided by 1 plus alpha by 2. Everything is multiplied by total pressure, but total pressure here is simply 1. So therefore, it doesn't matter. Partial pressure of O2 is equal to alpha by 2 divided by 1 plus alpha by 2 times total pressure. So let's insert everything. Therefore, Kp is equal to alpha divided by 1 plus alpha by 2 times alpha by 2 divided by 1 plus alpha by 2 to the whole power 1 by 2 whole divided by 1 minus alpha divided by 1 plus alpha by 2. 1 plus alpha by 2, 1 plus alpha by 2 we can cancel. So therefore, this will be equal to alpha times alpha by 2 to the whole power 1 by 2 divided by 1 plus alpha by 2 to the whole power 1 by 2 because I am bringing this thing down times 1 minus alpha, that is here. Now the condition given here is alpha is very less than 1. So this means 1 minus alpha is approximately equal to 1 because we are subtracting a very small number. Likewise, 1 plus alpha by 2 is also approximately equal to 1. So this means this entire expression is simply 1. So therefore, Kp is simply this term, which means 8 times 10 to the power minus 3, that is the value of Kp given, is equal to alpha times alpha by 2 to the power 1 by 2. So therefore, we can write this one as alpha to the power 3 by 2 times 1 by 2 to the whole power 1 by 2. So when we send this time, it would become square root of 2. So therefore, 2 to the power 1 by 2 times, I am writing 8 as 2 to the power 3 and then times 10 to the power minus 3, and that is equal to alpha to the power 3 by 2. Now we have to find alpha. So therefore, let's raise both sides by 2 by 3. So in that case, 2 to the power 1 by 2 times 2 to the power 3 times 10 to the power minus 3 to the whole power 2 by 3 will be equal to alpha, because alpha to the power 3 by 2 times 2 by 3. So therefore, this would become alpha. So now we can add these two, isn't it, because the base is same. So therefore, 2 to the power 7 by 2 times 10 to the power minus 3 to the whole power 2 by 3 is equal to alpha. So this is the expression we have. So let's distribute it inside. If we do that, then 2 to the power 7 by 2 times 2 by 3 times 10 to the power minus 3 times 2 by 3 is equal to alpha. So this means 2 to the power 7 by 3 times 10 to the power minus 2 is equal to alpha. 2 to the power 7 is 128. So therefore, cube root of 128 times 0.01 is equal to alpha. We know that 4 to the power 3 is equal to 64. So therefore, I am writing it this way. Cube root of 128, I am writing it as 64 times 2 times 0.01, that is equal to alpha. So therefore, alpha is equal to 4 times cube root of 2 times 0.01. So therefore, this is equal to 0.04 times 1.26, because cube root of 2 is approximately 1.26. It is exactly equal to 1.2599. So I am taking it as 1.26. So therefore, this is equal to 4 times 10 to the power minus 2 times 126 times 10 to the power minus 2. So if I multiply that, then I would get 5.04 times 10 to the power minus 2. So which means 5 is the correct answer. So 5 is the correct answer here.